Here we have the general solution of our cosine function. So once again, unfortunately, this is something that you do just have to memorize, but it's a little bit easier than the sine function, isn't it? So the general solution for this is just 2n pi plus or minus inverse cosine of alpha. Now, you can see it's 2n times pi, and that's because when you think of cosine, it's going to be when we have this as 0 and this is pi. Pi on 2, 3 pi on 2, and our first, second, third and fourth quadrant. With cosine, it's positive in the first and the fourth quadrant. So you can see it's always going to be 2 pi minus that to get you the angle in the fourth quadrant, and then plus another one to get to the next quadrant. So can you see how that's why it's 2n pi? So that's as much as I can explain for this one. So I hope that does help a little bit in memorizing this. All right, let's see how we do apply it now in some questions. So in question 29, let's find the general solution of cosine x equals to 1 on 2 in terms of pi. So this is our general formula, right? Now we just need to substitute alpha for 1 on 2 and think to ourselves cos of what equals to half. That's pi on 3, and we just leave that as is. So remember, the n value is what makes it a general formula because it can be any value. So n is just any integer. So therefore, for the general solution, we must leave the n in there like that. Great, let's go on to question 30 here. So we want to find the general solution of cosine x equals to 1 in terms of pi. So this is our general solution of 2n pi plus or minus inverse cosine of alpha. Change that to 1. Think to ourselves, cos of what equals to 1? That's 0. So we can just write that as 2n pi as your general solution there. All right, let's have a look here, question 31. So here, we want to solve cosine x equals to half, but for a specific domain of 0 to 2 pi. So similarly for what we did with sine question, we want to use a general solution, but we want to use that to find out the values. So we've just substituted half into the general formula there, and we worked out that cos of pi on 3 equals to half. So just substitute pi on 3 there. And now we actually want to work out the values. So remember how I said always start off with n equals to 0? So substituting in n equals to 0, essentially we just have, this just becomes 0, doesn't it? So it's just plus or minus pi on 3. But since it must be greater than 0, therefore x can only equal pi on 3 for that domain. So we worked out one value. Let's move on to n equals to 1 now. So we have 2 times pi plus or minus pi on 3. So we have 2 pi plus pi on 3, which is 7 pi on 3, or 2 pi minus pi on 3, which is 5 pi on 3. Now the 2 pi plus anything will be too great for this domain, so therefore it can only be 5 pi on 3. Now when we substitute in n equals to 2, we get what 2 times 2 pi, which is 4 pi. So you can see that's already going too large. Whereas negative 1 gives you negative 2 pi, which even plus pi on 3 doesn't make it greater than 0. So you know on either side it doesn't work. So this is the only numbers that work. So therefore, because we use this between that domain, thus x must equal pi on 3 or 5 pi on 3 specifically for that domain. So you can see here we can also work out the values just by using our general solution there.